right, I guess time's up. Welcome everyone. This is the Ranger talk, which is end-to-end security and auditing and big data as a service. And my name is Nanda Vijaydev. I work for a company called Blue Data, and here I'm with my colleague Abhiraj, who's an engineer at Blue Data. So I think, I'm guessing since you guys are here, there are two important concepts here, right? There is security and there is big data as a service. So this talk is about how those two come together. So we'll kind of look at what big data as a service is for some time and then look at the security aspect of it and see how those two come together. All right, so there are a lot of definitions we've heard about as a service. Infrastructure as a service, platform as a service, big data as a service, you name it, there are the as or SaaS concepts there. So when you talk about infrastructure as a service, you're looking at hardware, Docker containers, network, VMs, those are made available as a service. And then when you look at platform as a service, it's one level up, right? It is databases, or it is the websites, or now it is more like Hadoop and Spark. So heavy duty backend applications offered as a service is your platform as a service. So what is big data as a service? It's a combination of both, where you have these applications which also have to take into account that there is infrastructure which probably needs to scale. There is infrastructure that needs to be available on demand. So it is applications along with infrastructure which makes big data as a service. You guys probably heard a lot of talk about the BDAS, or big data as a service, this morning. And Blue Data is one such company where we offer a product which deploys big data as a service both on-premise and in the cloud. So when you look at these applications, when we often work with the customers, we see that it starts off with one marketing group. Maybe they have identified the specific use case, and they've gone ahead and implemented their 360 customer view, right? They may have started on HTTP 2.2 or 2.3, and then you realize IT has gone to another conference, or they have the need of a larger user base in mind. So it is not just about one use case. Now they have to think about maybe there is a streaming use case somebody is interested in, and maybe Spark, and there are other groups. So they may actually look at a holistic approach, and they are probably standardizing on something like a data lake, which is HTTP 2.4. And then you take individual groups into consideration. When you onboard people with different skills and different backgrounds, they have their favorite applications. There is a reason why people like the applications they like. It's not just about data for them, it's the workflow. It is the user interface, it's the kind of algorithms that they can run. When you look at all that, then they don't really care about where the data comes from. So you still want to keep the data as much as possible in something like a data lake, and you cannot force people, everybody to say, if you're doing things this way, you're going to change and start doing it a different way. It is not going to work. So how do you make sure that you can bring them on? And this is the only way you can democratize Hadoop, and then also provide them the necessary data that they want to use. Right? So why big data as a service? Quickly, the compute side of story, like we talked about, is as the set of applications grow, as the user base who have different use cases grow, you see that the more and more applications would want to interact with the data in Hadoop. And as much as we want to standardize on one version of Hadoop, somebody is doing QA, somebody is testing a feature, somebody is doing something else which is probably not in the Hadoop ecosystem. So the amount of applications will also be different. And all said and done, you will still have things like NFS, which we don't want to get into now, but they are their own set of storage that cannot be completely taken out and scooped into a system. And something that people are familiar with when you talk about big data as a service or this type of infrastructure, Amazon AWS and S3 has set a model that people have gotten familiar with, right? There is data in S3, irrespective of what compute you're running. You could be doing Amazon Elastic MapReduce, you could be doing Java on it. Irrespective of what you're doing, data eventually comes into S3, and then you could bring up another application and you can start using that data from S3. So that model, or having something similar to that, on-premise or even on the cloud for a variety of applications is really what the customers are looking for to democratize Hadoop. So data side of the story, again, we talked about where you have Hadoop for a reason. You don't want to have many duplicate versions of Hadoop. You want to have this one big cluster or one data lake. But if you think about how you're going to make the system available to all users or secure the system, it can be tricky considering what Hadoop actually is. We'll get into that in a little bit. And then if you have a very restricted access, some people overcome this by actually having some kind of a staging cluster, but then you can't replicate everything that you have in production. It defeats the purpose of having one large data lake. And one other thing that gets unnoticed is when users have things like small files, when they're working in R, SAS, or more desktop-based applications, they always bring their own files into the analysis. And by locking down everything in Hdfs or in everything in Hadoop, it is harder and harder for them to make that as part of their analysis. So that is the big data as a service aspect, right? Now, if you look at the Hadoop side of things, Hadoop's really a collection of services. I mean, probably a lot of you have already, you're working on Hadoop and you're learning about more services. But when you look at this from a security perspective, you will see and appreciate why something like Apache Ranger actually makes life easy and a whole lot of sense, right? I'm going to, here, let's draw a comparison between what is a table in a database and what's a table in Hadoop, right? That gives us a better understanding of the challenge and appreciation for what Ranger can offer. When we talk about a table in a database, there is an instance, or there is a schema, there's an instance, and there's a table. So you have certain types of access given to it. You have insert, you've granted insert privileges, you have granted query privileges, select or insert or delete. But in Hadoop, a table is not just a table, right? Hadoop has a table translates into, you have data is in Hdfs, metadata is in Hcat or some kind of a Hive meta store, and then processing is happening through your Hive server 2, turning that into MapReduce jobs. So there are already 3, 4, 5 different types of services involved. So what does it mean to secure a table? What does it mean to secure a data? That's where you will see that it is a challenge and an opportunity, because once you tie it down to a specific metadata or a table is this row and this column, you lose the ability to actually process the raw data because different people could use that differently and process it differently. So if you specifically look at maybe there is a table called customer and it has a name and phone number and different things, underneath in Hdfs, it could be in a folder called user customer. So if you secure the customer table and secure specific columns of that saying name and phone number, you're probably going through Hive Server 2 and you're providing a security and authorization at that point, but you may not have secured the Hdfs itself. So somebody may still go directly to user customer and may look at, they may have access to read, write, do whatever you want with that, and in that case, Hdfs doesn't know how people are looking at it as, is it a table, is it a column, because it is, it's a raw file which can be Avro or Parquet or whatever format. And how do you make sure that all these different levels, when you talk about security, how do you look at it from this perspective, right? So Ranger is this pluggable framework where all the different services of Hadoop can be viewed in the concept of, okay, I am going to secure this group, this person, and give them these privileges. You can look at it holistically, and each one of the service that I mentioned can authenticate directly against something like an Active Directory. So the authentication is taken care of, but authorization now you can see, okay, if I have to secure this table, I go to Hdfs, and at Hdfs name node service level, I lock down the data itself. Then I go to something like Hive, which is Hive Server 2 based authorization. Now I'm going to lock down their access through Hive Server into the tables and columns, and even processing. Can this person go to this queue, and what are the different things they can do? So this is a framework. Before something like Ranger, first there was no security. Whatever Hdfs ACLs offered, that was the security. And then on top of that, then you had a way to actually go to each one of this, configure some XMLs. You are in the space of editing. You have no idea what the holistic picture is. So with Ranger, you can see either using a web UI and keeping the big picture in mind, or through APIs for those who prefer API access, you can go and make sure you're giving the right level of access to the right service in Hadoop. So this is the big thing where it plugs into each one of these services which form the big Hadoop ecosystem. And since it's an extensible, pluggable framework, if you have one of your own applications in this ecosystem, you can make sure that you extend this API framework, you add your own custom plugin to this and control it through a central UI. Right? There are different, like we talked about, a couple of different services, and there is its own authorization that you can enable. I think there is a session this afternoon about Hive Server 2 authorization, and probably there is one more about Yarn. So we will stick to Hdfs authorization here, mostly because when you are thinking about big data as a service, it is the data that's the premium commodity, right? Your compute can be different, your compute can come from a different service. So when you look at data, how do you lock it down, right? So in your data lake, say this is a secure Hdfs, and in your data lake, you have Hdfs policies defined. Here I have a couple of policies. There is a secret folder, and there is a marketing policy. In the marketing policy, you can see that the user group is still marketing at the bottom, and then there are these two users, Alice and Bob, who may belong to the same group. But if you think about how POSIX ACL works, there is the owner, there is the group, and there is other. There are only so many different combinations you could do with the group. Pretty soon you'll run out of choices of how you want to actually make someone be able to access this if you just stick to that. So with Hdfs policy management in Ranger, you can lock it down. Abhiraj will talk more details about it. You can lock it down, and you can give very selective access to different users at very different levels. They can be all, they can be a particular path, and they can have overlapping type of access where you have a lot greater control about how you want to secure Hdfs. So now we've kind of understood a little bit about security and big data. So how do these things work together, right? When you look at these things, there is identity management in the data lake itself. So even without all those surrounding ecosystem applications, even within a data lake, there is, because it's a combination of so many services, you have a challenge, and you want to make sure you identify the right user, the right set of services, having right access to a data. And then you have user identity at the application level, and then how do you make sure that it is the same person all the way through, right? So if you kind of take it a level further, within the data lake itself, there are the 5, 6 fundamental concepts. We won't get into each one of those, but at a high level, you have authentication, authorization, auditing, and then you also have data integrity, data at rest. But just for the authentication, authorization, and the auditing part, generally you have LDAP integration. Most companies have LDAP. And then for service to service, because it is such a heterogeneous environment, for service to service authorization, you want to make sure that it's Kerberized, so it is secure. And then what that means to the applications one level above is, it is now from IT or from people who have deployed the data lake, they're happy, it is all secure. But then what does it mean to the application one level above? You may want to Kerberize that too, or you may not want to, because Kerberizing compute can be painful, and some compute frameworks may not even allow you to Kerberize. They may not have that feature. So how do you make sure that you can actually still access the data from data lake and pass the necessary information, right? One, you extend that, the same LDAP that is used to authenticate your basic Hadoop cluster or the golden Hadoop cluster or whatever you call data lake, that same LDAP can be used to also access control your compute layer. What we do in Blue Data is that compute layer is on the top, which is your application layer. Those are Docker containers. So we spin Docker containers, and when, irrespective of the application that's running in those Docker containers, we make sure that the containers that come up are by default integrated with your LDAP in the enterprise. So if you run a Spark shell, or if you run a H2O Spark shell, or an R from command line, you are already authenticated, and you are the same person who will be talking to the data lake eventually. And KDC, like here it's on the left-hand side, can be extended to Kerberos compute if you have tools. We have seen people running multiple Hadoop instances also. They have 2.2, 2.3, 2.4 running in parallel, still wanting to access from the data lake. And you may want to Kerberos the compute if a lot of our users, they don't prefer to do that as long as you provide the basic level of security. So the last one is, really when you are logging into those containers, or when those applications are making a request to the data, how do you propagate that? One, you could copy all the data to each one of that, and each one is its own world and it's all secure, but that's really not practical. How do you propagate that user's information all the way down to your data lake? Right? Something like BI applications, not all of them actually pass the end user information. They do go through one super user credential, and when you look at the auditing on the HDFS side, you see like the application XYZ is the one that accesses the files, but maybe this service below trusts that application XYZ has done its due diligence, and they have authenticated and authorized the user and their roles. But some other applications, as much as possible if you can, if Joe or Bob's logging in, try to see if you can send it all the way. In that case, you are running into, especially if it's a Kerberos compute, is everybody going to have a principal, Kerberos principal? That can be quite painful. And in the world we work with in our customers, there are Hadoop clusters also in the application layer on accessing Kerberos Hadoop clusters. So we kind of have a concept of impersonation. I don't know how many of you are familiar with Hive impersonation, where Hive has one principal, and that is the one that's going to talk to HDFS name node service or Yarn service, but eventually when the application runs, it is the end user. It's through Hive principle, it piggybacks all the way down, and when you see HDFS audit, or when you see Hive audit, you can see that it is the real end user. Even though they didn't have Kerberos principle, their credentials were used all the way down, because it uses the concept of impersonation. And I think Abhiraj is going to talk a little more about how that translates into direct HDFS access, where not everybody uses the Hive that's running on the data lake or the pig that's running on the data lake. They may just do a direct HDFS access. With that, I'm going to pass it off to Abhiraj.
So Nanda, yes, there are a few more slides. You talked everything here, so I'm just going to move past. Hello, everybody. So this was, it's not there. Okay. All right. Nanda just described how passing down the user identity is very crucial to make sure that we enforce authorization and auditing at the HDFS level in your golden or global HDFS data lake. So passing down the user identities essentially boils down to how users connect to HDFS, and how users connect to HDFS boils down to how users actually authenticate to HDFS. So these are two standard ways in the Hadoop ecosystem components that are used for authentication. So first is users directly connect either via simple or Kerberos authentication, standard stuff. And the next is users connect to HDFS via a super user, which in turn authenticates via simple or Kerberos. Simple is not recommended here because otherwise anybody can come in and spoof and fake the identity. So let's look at these two approaches in more detail. Now, coming back to our multi-tenant environment, right? So we'll look at the direct connections first, and then we'll explore what are the limitations that are there when we are connecting directly to HDFS. So here, what we're seeing is users, Alice and Bob, are using their Kerberos principles to connect to HDFS, and here HDFS is also Kerberized. All of this is LDAP integrated, and Alice and Bob also have their Kerberos principles associated with them. So this is the standard stuff and works fine if it's a single Hadoop cluster. Now, the Hdfs audit logs will look something like this in this scenario. What we are seeing here is that users Bob and Alice has Kerberized, authenticated themselves with Kerberos, and it has used Hdfs RPC protocol to connect to Hdfs, and it is accessing the /user/data. So in this case, the effective user at Hdfs level is still Bob and Alice. So we end up enforcing the policies that are defined in Ranger. So that for specifically for Hdfs, and Nanda just described how those policies are defined for specific users. So over here, if Alice and Bob have the correct permissions set, the authorization will happen. And at the same time, you will get the auditing that is provided in the individual services like Hdfs here and in Ranger, the Ranger auditing part. So to summarize the use of direct connections, right? So in a single Hadoop setup, if there is a single distribution, single version, everything is Kerberized all across, all applications are tightly coupled with each other, this will work just fine, right? But if it's a multi-tenant and multi-application setup, as Nanda explained, like you may not have the choice of Kerberizing all of your compute and services. Some services just may not support that, right, as Nanda explained. So in that case, we cannot really make direct connections to Hdfs, especially if your global Hdfs is Kerberized. The other thing is, you may not want to Kerberize your dev and QA setups, right? All you care about is accessing your data, which is stored in a centralized location. You don't want to copy the data to multiple clusters because the data is locked down and cannot be accessed by individual services. And the last thing is the Hadoop versions need to be compatible, right? So we notice that here users are authenticating themselves with an Hdfs RPC connection. So if there are different versions across your, like in your Hdfs data lake, and if there's a different version in future in your compute environments, there may be a mismatch there, right? So this is a big limitation when you have a multi-tenant, multi-application set, right? And so as I mentioned, you also want to make sure that you don't duplicate your data as much as possible. So let's see how using super user connections can help us here. So let's briefly understand how this works. Again, this is standard stuff. Super user essentially performs actions on behalf of other users. It is also called impersonation or proxying. And many Hadoop services like Hive, Vue, Oozie already support this feature. Registering or configuring a new super user which has these privileges is fairly easy. You define these properties in your core site.xml. So here what we are saying is a super user called data tap is being registered, and a wildcard here for host indicates that the request can come in from any host. Also, the groups part here indicates that users from marketing group can access the data or can piggyback on this particular super user. And this can very well be a wildcard, meaning that any user can piggyback on this particular super user. So let's see how this would be useful in our multi-tenant environment. So coming back, now what we are doing is we are introducing this data type caching service. So we won't get into the details of how this works. That would be a different talk. But like the analogy here is that this service is similar to what Hive, Vue, or Oozie are doing, right? So here the caching service is essentially when you have this compute and storage separation, it has been given a super user that we just defined in the core site.xml. So Hdfs in your global data lake is already aware of that user as a super user. Now that is registered here in this caching service, and what is happening is users like Tom, Alice, and Bob are now connecting to Hdfs via the data type caching service, and they're using the super user. So in this case, notice that you don't have to have a Kerberos principal for user Bob, right? Because the authentication is going to actually happen via the super user that we registered. So this can be useful in environments like dev and QA or where you don't want to Kerberise your compute, or for services which do not support Kerberos yet, right? So they can still access the global data in your golden HDFS data lake, and as long as everything is LDAP integrated. That is a key here, otherwise this won't work. And note that in this scenario, direct connections, as noticed in the last line, are still a possibility. If some applications want to directly connect to HDFS, that still is going to work. Now, coming back to the audit logs in HDFS, this is the difference that we see in the HDFS audit logs. What we see here is user Bob has now authenticated as a proxy via data tap, which is authenticating via Kerberos. Same thing, the protocol is HDFS RPC. You are trying to access the same data /user/data, but note that the effective user here is still Bob. So as long as everything is LDAP integrated, your Ranger policies are still enforced because the policies are defined for Alice and Bob. Right? So to summarize the use of HDFS super user connections, so we identified a few limitations when using direct connections, right? So let's see how like they are addressed here. So yeah, like we discussed, the applications need not be Kerberized, and if they don't support Kerberos, that works too. One other thing here is if you are connecting to global HDFS via a data tap service, then the version incompatibilities get abstracted out, because now and this is specific to data tap service, wherein it will support multiple versions of the protobuf versions supported in HDFS, so that like if your applications are running an older version in your compute environment, that will work too. So the last thing here is because you are able to access the data from your global HDFS data lake, you end up making sure that the data doesn't get duplicated here, right? Because in the absence of this, the other option would be to like have the data copied over to your dev and QA setups or staging clusters, and then access that data and get the job done, right? And finally, for all of this to work, as we discussed, LDAP and Active Directory integration is very, very essential. So for the last part, we are going to have go through a series of screenshots and see how all of this works in action. So we'll be taking a Hive editor in U example, and note that this U is running in one of the compute environments, and it is trying to access the data that is defined or stored in the HDFS data lake. Now the first thing is like we are locking down the permissions on your data lake. Here what we are saying is the path /user/secret has 000 permissions, so that nobody can come in and access to it directly. The other thing here is we are setting the umask for HDFS on your data lake to 077, so that only the owners get access to the data that is stored in HDFS, and this is a requirement for Ranger authorization to work. The next is like how Nanda explained, we are defining the Ranger policies for this path /user/secret, and the policies will be applied in a recursive manner. Audit logging is supported, and what we are saying here is users Nanda and Abhiraj have some permissions for this particular path. So what we're seeing here is user Nanda has read, write and execute permissions. User Abhiraj has write and execute permissions. Now, briefly, the data type caching service is the one that is pointing to this remote data, and this is how it will be configured, and during this configuration, you are also providing the data type Kerberos super user principal that we just defined in the global HDFS, and provide its key tab file over here, so that this is available for all of your compute environments. Now, coming back to the Hive editor example, note that the user here is Nanda, and this is LDAP integrated. Now, it is trying to create a table called secret in the path, which is dtab:// remote secure HDFS that we just defined a slide ago, and it is trying to access the path /user/secret in the global HDFS data lake. So essentially, just like how HDFS:// is used to connect to HDFS directly, dtab:// defines the connections via the DataDAP caching service. Now, this operation is going to succeed because Nanda has the correct permissions defined in the Ranger. Next, the same user, Nanda, tries to access that data, tries to read from it. Now, since Nanda has read permissions defined in the Ranger, this is going to go through. Finally, user Abhiraj here does not have the read permission, so this operation is going to fail because it doesn't have the correct permissions. Right? And lastly, what we have here is the Ranger Audit Log. So we looked at the HDFS audit logs in like few slides ago, and this is how the Ranger Audit Logs will look like. So here we can see Nanda has been allowed access to path /user/secret, and Abhiraj is not, it's denied. So note that we are defining the Ranger policies for your global HDFS. You're accessing that data from your remote compute environment. It's a Hive editor in Hue, like a different distribution that is accessing this data. But at the end of the day, the policies, the authorization policies get enforced, and you get the right amount of auditing that is needed. So as long as everything is LDAP integrated, this will work. So that is it for me, and I'm going to request Nanda again to give the closing notes.
Yeah, I think we're probably between you guys and the long lunch lines. So, where's the clicker? Sorry. Right. So I think big data as a service, when you guys hear it from Hadoop vendors, technically it becomes Hadoop, but when we see it a customer, it's really more than Hadoop. It's Hadoop plus there is BI, ETL, analytics, data science. Some people want R, SAS. There's all kinds of stuff. It is a larger, ecosystem. And when you are in such a larger ecosystem, diverse set of applications, lot of use cases, security is the most important concept. So you want to make sure that who the user who claims to be the person is the one who is accessing all the services and is passed all the way down. And the third one, no-brainer, data duplication is not an option. So what really works is having something like a global user database. I think we've iterated that a few times, that LDAP and Active Directory integration. A lot of people between LDAP and Kerberos, there is some confusion, but for authentication and authorization, LDAP integration at all levels helps to make sure the integrity of user is maintained throughout the ecosystem. And I've tried to do security before Apache Ranger. It was painful, and this definitely helps a lot to have that single UI and a holistic view or a vision of what you're trying to do and how you're trying to control the user and their access. So with that, you guys can, if you guys need more information, we have a booth. You can come to us, and that's Abhiraj and my information. And if you guys have any questions, we'll stick around for a while.